Okay, so starting here with problem 10. Notice that we have not just an x, but a negative x for my angle. So that's usually a good place to start, is trying to get rid of those negative x's and change everything into x terms. So I start off by taking what's on this left-hand side and writing it down. And I know that my next step is going to have to get rid of those negative x's somehow. And I still got this great big old long thing I got to write down. So I'm going to have to write pretty small to get this all on my paper. So I've got tan negative x cotan of x plus cotangent of negative x tan x equals something. So I look at my reference sheet and find on the bottom of the front, there's my even odd identities. And this tells me that tan of negative theta equals negative tan theta, right? Theta x, same thing, right? So I need a negative out front here. So I have negative tan x. I've got cotan x plus, now I need to get rid of this negative x that's in the cotangent. So again, I put the negative out front here. So I've got negative, and you could have just written this as minus if you wanted to, minus cotan x tan x. Now from here, I've got a couple of options. If you like to work with reciprocal identities, right? So I know that tan is 1 over cotangent, or cotangent is 1 over tan. Then you can substitute in one of those if you want to. If you want to change everything to sines and cosines using your quotient identities, you can do that as well. It doesn't really matter. I'm going to change cotangents to 1 over tan. Now I've got this first part of my expression with the tangent on top, tangent on the bottom, so they can cancel. So this is -1. And here I can cancel the tangents. So this is -1, -1, -1 is -2. And that's what I was supposed to get right there. Okay, problem 11. This is actually one of those things that we skipped from section 3.2. So we're going back and doing it now. And that is dealing with sum and difference formulas. And it's really not that hard to do, because you have your formula right here for the sine of a plus b. Actually, your book uses alpha and beta Greek letters. I'm just using a and b, just because they're easier for me to type. So my alpha, or sorry, the alpha here, or a, is going to be replaced with x. I'm going to replace b with pi in this expression here. So I can, first of all, start off by writing down the left-hand side of this identity, then equals, and I'm going to use this identity here, and I'm going to substitute in x and pi here. So I have sine x cosine pi plus cosine x sine pi. Let me zoom out here a little bit, or move, I could just move that over a little bit there. So hopefully you can see how this formula on your reference sheet got used to create this sine, cosine, cosine, sine. Well, from here, I can use my calculator or my reference sheets with my table of values or my unit circle, whatever you want to do to figure out what cosine of pi is. Okay, so cosine of pi is -1. Sine of pi is 0. You know what, I'm going to go ahead and put parentheses around both of those, just because I think it looks prettier that way. So sine x times -1 is negative sine x. 0 times cosine is just 0, so this is just negative sine x. And that's it. Notice how on my problems, I start off with the left-hand side of the identity that's given to me. I write that down. I do my first substitution to get to the right side of an equation. And then I work all the way down here to where this ends up being the same as this right-hand side of my original identity. And I'm doing this vertically. Right? After this, we'll do the first part horizontally, and then everything else is vertically. So I've got this left-hand side equaling to the right-hand side. Does that make sense? I have cosine of pi minus x equals negative cosine x. That is what I am trying to prove. So I'm going to start off by writing down what's given to me on the left-hand side. And I know that this is going to be a sum or difference formula. Actually, I know it's a difference formula because it's a subtraction sign. It's a difference formula. So I've got cosine of a minus b. That's what this is going to follow. So I have cosines a, cosine b. So I have cosine pi, cosine x, then plus, no, not plus, hang on. Is it plus? Yeah, plus sine, cosine. No, sine. Getting myself confused. I'm looking at the wrong problem here. So I've got cosine, sine. All right, so cosine of pi is -1. Sine pi is 0, and then that's times sine x. And this is going to give me negative cosine x plus 0, and that is negative cosine x. Okay, let me see what my next one is. There's one of these problems I had a typo on, and I think it was on the back part with your homework problem. This problem has fraction in it, so I'm going to get a separate sheet of paper here. It's probably going to take me more space, need more space than what I have on that paper. So cosine a plus b over cosine a cosine b equals 1 minus tan a tan b. That's what I'm trying to do. Really, you need to be sure that, when you're working with identities, that you are using the same angle, whether it's alpha or x or whatever. You need to be sure that you're using that same angles. So this is usually a good place to start, is to get rid of this thing. And then you'll have everything in terms of A's and B's for your angles. So I've got cosine A plus B, cosine A, cosine B, all right? So I need to take this and rewrite it using this formula here. So I have cosine alpha, cosine A, cosine B, minus sine A, sine B. All of that is divided by cosine A, cosine B. Okay, so from here, it may not be obvious where you would want to go from here, because you can't really combine these two things because they have different angle measures. Same thing with here. You can't combine stuff. You can't use most of these identities over here when you have different angles. So look at what you're trying to prove, right? You want this as 1 minus something. You want this as 2 different terms. Right now, I have this 1 fraction, and I would like to be able to get 2 terms out of that. Well, I can split this up because I've got a subtraction here in my numerator. So I can write this as cosine alpha, cosine beta over cosine alpha, cosine beta, minus sine alpha, sine beta. I keep going back and forth between alphas and A's and B's. I apologize. I'll try and stick with A and B. All right, so now I've split that fraction up into 2 different fractions. And we went over this last time we met, I guess it was Wednesday. I know that if I have a fraction, say 2/19 plus 5/19, I add that together and I get 7/19. Well, really what I have here is this intermediate step of 2 plus 5 over 19, which is 7/19. So I can actually start here and go backwards. And that's what I'm doing here, is I want to take that fraction and separate it into 2 different fractions. Well, this is just 1, right? So anything divided by itself is 1. And what I would like to do here is to try to get this in terms of tangents, of A's and tangent of B's. So I can write this out. I'm going to write this out as sine alpha over cosine alpha times, just did what I said I was going to do, sine A over cosine A times sine B over cosine B. Okay? So I can see I've got these 2 terms that I split up. This is tangent of A, this is tangent of B. 1 minus tan A, tan B. And that's what I was supposed to prove. So I'm done with problem 13. Any questions with that? Okay, now problem 14, I have sine and cosine of 2x in my problem. So 1 plus cosine of 2x and sine of 2x equals cotangent of x. That's actually a couple of different ways that you could do this problem. You could say 2x is x plus x, and then use a sum or difference formula. You could say sine of 2x is x plus x, and then use a sum or difference formula. But we also have what's called double angle and half angle formulas on the back part of this. So I can use this formula, and this is from section 3.3 that we skipped. So we're basically doing 3.3 right now. I just take 2 theta and substitute in this down on the bottom, but I need to figure out what it is that I want to substitute on the top for cosine of 2x. I have 3 different options on what I can do to substitute in for cosine of 2 thetas. Let me first of all write down the first part of this problem. And then we'll go back and think about this and figure out which one of those formulas do I want to use. Well, I know the bottom part of this, I only have one option, 2 sine x, cosine x. What do I want to end up with? I want to end up with cotangent. And I know cotangent is cosine over sine. So I want my cosines to cancel out, and I want to have just this sine on the bottom. Well, if I want cosines to cancel out, then I need cosines in the numerator. Does that make sense? I guess that would probably be the thing that would make the most sense. 2 cosine squared x minus 1. Oh, and then I have 1 plus that, right? 1 plus that. So the 1 and negative 1 is going to cancel. So I have 2 cosine squared x over 2 sine x cosine x. So now I have the 2's are going to cancel. And you know, it may seem kind of obvious that the cosines are going to cancel, but what I'm going to go ahead and do is to rewrite that cosine squared as cosine times cosine. And then I have sine x times cosine. And now I can see that my cosines cancel. I've canceled out the 2's. I'm going to cancel out the cosines. So I'm going to have cosine x over sine x, and that is cotangent x. And that is what I was supposed to end up with, right? Cotangent x. I had originally planned for y'all to do problem 5 as a homework problem, but it's really more lengthy than some of these other problems that we have done in class. So I want to work through problem 5 with you in class and to get y'all started on it, and then have y'all finish it up, and I'll help y'all with that. All right, so problem 5, I have sine x over 1 plus cosine x, 1 plus cosine x over sine x equals 2 cosecant x. That is what I am trying to prove. Notice I have 2 fractions, 2 terms, and I'm trying to end up with 1 term. So a good bet is that I need to add those fractions together. And if you look a little bit closer at these problems, there's really not much that I can see that I can do to either one of these fractions. So I am going to get a common denominator and add. It may not be the quickest way to my answer, but I think it's the most obvious way. When you have 2 fractions, add them. Right, so I've got sine x over 1 plus cosine x. It's my first term. This is my second term. Now, in order to get a common denominator here, I'm going to need to multiply the numerator and denominator here by sine. I'm going to need to multiply the numerator and denominator here by 1 plus cosine. So I have sine x times sine x, 1 plus cosine x sine x. That's my first fraction. My second fraction, I'm multiplying numerator and denominator by 1 plus cosine. You know what? I'm going to rewrite this because I wrote too big and I cannot fit it all on the same paper. All on the same line, I should say. Now notice that when I'm writing down 1 plus cosine x, I am putting that in parentheses, right? Because that whole thing is being multiplied on top and bottom. In my numerator here, I started off with 1 plus cosine x. That needs to be in parentheses as well. Right? So from here, you are just going to multiply everything out. And I think that once you do, then it's going to be hopefully pretty obvious what your next step should be. So I wanted to give y'all a minute to work on that sum on your own. While y'all are doing that, I need to be sure I take roll. This first fraction, I have sine squared x in the numerator. Now, the denominator, you've got a couple of options for the denominator. You can multiply this sign out, distribute, or you can just leave it like it is until later in the problem. It doesn't really matter which one you do, but I'm going to leave it like it is because I know that eventually I want stuff to cancel out where I just have one term. And if things are going to cancel out, that means that this bottom part of my fraction probably needs to stay factored in order to cancel stuff. Does that make sense? All right. Again, if you wanted to multiply this out, you can go through the problem. You eventually just have to factor it out again. No big deal. So I'm going to leave this like it is, except for I'm going to put the sign first like I have over here. Just because you normally see this written with, if it just has one term, you normally see it first and then the parenthesis part. Now, in this second fraction, when you multiply out the numerator, you FOIL first, outer, inner, last, first, outer and inner, last. And notice I did not put in every little step on how to multiply. I just went ahead and FOILed that in my head, and that's okay. So I've got sine x times 1 plus cosine x in my denominator. So I've got two fractions with the same denominator. Remember, the whole point of me doing this is to try to get this into one fraction. So I can write this as one fraction. And when I do, I'm going to put my sine squared and cosine squared next to each other. So I have sine squared x plus cosine squared x, and then plus 1 plus 2 cosine x over sine x 1 plus cosine x. Now, why do you think that I wanted to put the sine squared and cosine squared next to each other? But exactly, Pythagorean identity, sine squared and cosine squared is 1. So this is 1 plus 2 cosine x. So let me give y'all a minute to finish out the problem from here. What do I do once I get here? Remember, I'm trying to get 2 times cosecant, and cosecant's 1 over sine. So I've got a 2 that I'm having to deal with in the numerator, so that looks good. I've got a sine in the denominator, so that looks good. But I've got this 1 plus cosine that I wanted to get rid of. What am I going to do to this problem next? what can you do to the problem? I could split it up into two different fractions. I could multiply out the denominator, which is not really going to help me. If you look at your strategies that I gave you, that piece of paper that has all of these strategies on it for working with fractions, not really working with fractions, but just in general, your strategies, you can add, you can multiply, apply trigonometric identity, write everything in terms of sines and cosines, and factor. I can factor out of 2, right? Because I want these things to cancel. So if I can factor out of 2, then maybe I can get something to cancel, and I can. Now I have 1 plus cosine in the numerator and denominator. Remember that you cancel factors, you don't cancel things that are being added and subtracted. So if I want something to cancel out, I need to probably factor. So this will leave me with 2 over sine x. That's the same thing as 2 times 1 over sine x. And 1 over sine x is cosecant x. And this is what I was trying to get to.